In a regular polygon of n sides, each corner is at a distance r from the center. There is a regular polygon. Let's say, suppose it's a hexagon. Okay, regular polygon could be anything. Okay, and each side, each corner is at a distance r from the center. Got it? Now, what's the question? Identical charges are placed at n minus 1 corner. N minus 1 corner, that is not all corners. One is empty. So suppose plus here, plus here, plus here, plus here, and plus here. Not it. Clear or not clear? Diagram understood? Yes. One corner is empty. Yes. At the center, intensity is E. Intensity means electric field. Over here at this point. At the center, the electric field intensity is E. Okay? Yes or no? Yes. Okay, and potential at this point is V. How much is that? We have to find out what is the ratio of V and E. We have to find out what is the ratio of V and E. Clear? Everyone got that? Yes. So, now how to find all these? First of all, let's meditate. Potential vector or scalar? Scalar. Vector or scalar? Scalar. So due to first term, if it is kq by r, then due to second one also same. Third one fail. So in this case 5 or in general n minus 1. Clear or not? Because we are leaving 1 out and remaining all the n have charge. Clear? N minus 1 q by r. Now what about electric field? Electric field scalar or vector? Scalar or vector? So there are two ways to go about it. Suppose there is a positive charge. This opposite corner is right opposite to that. Yes or no? Yes. Okay, like that there will be symmetrical forces. Yes. Except one. Yes. So you can think that this one will not get cancelled. The one due to this positive charge, let's say like this is A and B and C and D and E and F. So the one due to D will not get cancelled, others will get cancelled. Got it? So due to one will remain. So this will be kq by r square. Do you understand? Yes or no? Sure, because due to one it's remaining, due to the others it gets cancelled. Okay. This is a method that is very easy to demonstrate for even number. But for odd you will have a little bit of problem. Right? But in general, there is another method. See, this empty corner here, this empty corner. Do you realize I can say there is a plus q charge and there is a minus q charge also over here? Then how much is the total charge? 0. Yes or no? Yes. Sure? Yes. Okay. So then there are 7 charges in this particular case. Yes or no? 6 are plus q and 1 charge is minus q. Did you understand? Yes or no? Yes. 7 3 2 here and 3 4 5 6 7. Got it? Yes. Okay or not okay? Yes. Now, what's going to happen? Due to the plus q plus q plus q plus q everywhere symmetrically placed, the electric field will be 0. All the plus q's are symmetrically placed around center. So they will mutually cancel each other's electric field. But this minus q will remain. Understood? Yes. So, if there is only one minus q and there is nothing else, then how much is the electric field? Kq by r square. Okay, and in which direction? Towards this empty, actually. The one that was empty. Did you understand? Towards that. Got it? Yes. Okay, so this magnitude of E and D. So, what will be done? B. B or D? B. Okay or not okay? B option. Got that? Everyone? Okay. એટલે આપકા આગળનો વાર ન લાગે તમે ખાલી આ પ્લસ q માઈનસ q બનાવો તો બાકીનું ફટાફટ. Right? 24. What is given? મને પૂછને એને શું પૂછે? Okay. Five side cap. Right. Fine. 24. A cube of metal. That word is very important. A cube of metal. Metal means conductor. Right? So a cube of metal is given some charge. So we are giving it some charge Q. So it would be probably spread out uniformly everywhere. Okay, now what to do? Which of the following statements are true? First, potential at the surface of the cube is 0. False, it's not 0, right? There will be some potential. Clear? Because there is a charge. Second, potential within the cube is 0. Same as here. So here 0 nothing, so here 0 negative. Is that clear? Because inside a conductor the potential is same as the surface. One of the properties. Got that?
Yes.
Okay, third.
Yes.
Electric field is normal to the surface of the cube. Yes or no?
Yes.
Property of a conductor once again. And last one. Electric field varies within the cube. Now, where you know that? Same as Can do it. 0. Same everywhere and 0. Uniformly 0. Okay. What is called 0 everywhere. Right. Next question. A metallic solid sphere is shown. Okay. And it is placed in uniform field. What does that mean? See, first there was a uniform field like this. And then someone placed a metallic sphere in here. Okay. So obviously something about field lines will change. So we have to decide now the lines of force. Lines of force means electric field. The electric field line will be according to which path? What do you think? This is a metal sphere. Okay, decide. Come on. 4 options are there. 1, 2, 3, and 4. Second. Keep card it down. Okay, time to recollect properties. First property. But first one that I told you was that electric field in electrostatics will be normal to the surface of conductor.
Yes.
Everyone, take that list out. Look at all the properties one by one. Okay, most prominent are as follows. Electric field at the surface is normal to the conductor. Okay, and its value is sigma by epsilon 0. Then potential at the surface is same everywhere. Potential in the body is also same as the surface. Electric field inside the body is always 0. And electric field in the hollow cavity is also 0 if there is no charge inside.
Yes.
Okay? Right. And all the charge of the conductor appears on the surface, never inside the body or never in the body. So આ બધા rules follow કરે એવી કઈ ફીલ્ડ લાઈન 1, 2 and 3 are wrong. સમજ પડી? They are going inside. That is not true. Okay or not okay? 1, 2 and 3 are going inside the body. That's not true. That's why the right answer is 4. Clear? Clear or not clear? Fourth is not normal. It is normal. Best choice. Look at 1, 2 and 3. Don't you think 4 is much better than the other ones? क्या टाइप નથી તને કે ખબર પડી આમ ટાઈપ એવું લખ્યું તો નથી ને કોપર ડોટેડ કર્યો ડોટેડ મીન્સ ગોઈંગ ફ્રોમ ધ બેક પણ એવું કઈ નથી ઓકે well then 26 find the force experienced by semicircular wires charge with the charge q placed as shown in figure. Okay, can you see the semicircular wire? Yes or no?
Yes.
Okay. Radius of the wire is r. Okay, actually radius of the circle, semicircle is r. Wire to radius r. Radius of the semicircle is r. Okay. And the infinite line, sorry, and the infinite line of charge with linear charge density lambda is passing through its center and perpendicular to the plane of wire. What do we have to find? Force acting between them. These are point charges or not point charges? If this is point charge, okay, then right now we are sitting on Mars. Okay. Here this is not a point charge. So what to do? If you want to find force, F equal to K divided by R squared. Yes or no? No. So U into E. Okay. So we will allow the line charge to create electric field. Can't happen in formula. Okay. So we'll say that force will act on the semicircle, SC for semicircle, and electric field will be created by the wire. Did you understand this?
Yes.
Yes or no?
Yes.
Sure. But there are further problems. If this is the wire and that semicircle is surrounding it like this, then do you realize that electric field of the wire is radial, like this in all different directions? Yes or no? Remember? Yeah, you can. Top view would be like this. This is the wire, a wire diagram, and electric field will be like this. Yes or no?
Yes.
Okay, where is the semicircle? Semicircle would be like this. Did you get that? So at different points of the wire, of the loop or semicircle, the force will be in different directions. Here like this, here like this, here like this, here like this, here like this. So everywhere the direction is different. Good friend. Okay. With the good friend. Integration. Is that okay or not okay?
Yes.
Right? Outside the comment પડી જાય ને કે આમાં કઈ સારું નથી થતું. Okay, so time for integration. Well, first of all, do you realize that it is the symmetry of the situation? There is an equal rocker. The force will only be upward, neither left nor right. Clear or not?
Yes.
Why? Because left side, right side, they are symmetric.
Yes.
So the force will always be vertical. So we are only interested in vertical component. Got that? We will only be interested in vertical component. More TAVR dropper. Okay. Let's take a small charge here, dq. This time, this charge will experience a force. Okay, let's say this is small angle d theta, and this angle is theta. Got that? And for force, let's say electric field is in radial direction. Does that make sense? You know how electric field is along the radius. So here electric field armature. So force will also be in that direction, df. Assuming everything is positive, then positive is negative.
Yes.
Got it? Or not clear?
Yes.
So let's find out how much will be that force. df will be equal to in magnitude dq into e. Okay, dq into electric field. Who created electric field? Wire created electric field. Long straight wire. Electric field created by long straight wire. Due to k lambda by r. R is the distance. Linear distance. Clear or not clear?
Yes.
Yes or no?
Yes.
Okay, that is clear. But like I said earlier, we are only interested in the vertical component, not in the horizontal component. અહીંયા theta is 4 something. So if I want to take vertical component, what will I have to do? Cos theta sin theta. df is like this. This is the angle theta here. Yes or no? Then df I want to take vertical. Cos theta sin theta. Okay, sure.
Yes.
So total force F will be integration. Equals B. Let's write it in form of theta. dq. dq, this is arc length. Yes or no?
Yes.
This is arc length. So arc length will be d. So lambda into r into d theta. Yes or no?
Yes.
Arc length is that r d theta multiplied by lambda. That gives you small charge. Fine?
Yes.
Sure. Everyone got that?
Yes.
This is arc length multiplied by lambda. Okay, so here. Lambda r d theta 2a lambda by r. પણ integration કેનું કરવાનું તો df નું નહીં, df sin theta. Do you remember?
Yes.
Yes, આવ્યું ને? Like I said, we only have to worry about the vertical component, not the horizontal. કારણ કે તો કટ જ થઈ જશે. Into sin. This is df into sin. For integration. So limit શું આવી જાય? theta will be અહીંયા લેવાય ને? theta equal to 0. And maximum આ બધે theta equal to 0 to 1 or 0 to 5. Fine. Do it over. Put the constants out. Okay, just one thing. This lambda is lambda of the loop. So this lambda will be q by pi r. Okay, that's not same as the other lambda. Thankfully, otherwise we would have made over to this. So go to this wire. Its linear charge density is not lambda. Read the page. Full linear charge density is given. Wire, the straight wire. What about loop? This is for loop. Yes or no? When I write d2 equal to lambda into r d theta, loop. For the loop, lambda will be q upon pi r. Why? Why q upon pi r? What's the total charge of the loop? Q. Yes or no? Yes. What's the total length of the loop? Pi r, circumference, half of the circle. Is that clear or not clear?
Yes.
So I hope you understood that here we have q by pi r instead of lambda for the loop.
Yes.
For the circle. Got it? We can q by pi r. So lots of things are cancelled. Got it? Done. This is what I am getting. Constants outside, right? To cancelled. Sorry, r cancelled and constants outside. Sorry, yeah, in the denominator, correct. So 2q into k. What's k? 1 by 4 pi epsilon 0 lambda by r, and then there is a pi also. Integration of 90 is minus cos theta. So when you put the limits 0 to pi, you get as 2. Yes or no? Yes or no? What then after some logo come down to 2000. Okay? Right? So this is going to be how much? 2 to 4. 4 cancel. So q lambda by pi square epsilon 0 half. Minus the super. Thankfully, it doesn't match with any of those quotations. So answer is minus number. But then for sine theta minus 1. 599 is not integration to the minus cos theta and cos theta and minus bar and 1. What the fuck? Whole અંદર minus લો છે બરાબર ને બાર માં જ માઈનસ કરો માઈનસ okay मैं तो प्लस कह दे because to be very frank these are my methods you may not agree with them मैं तो ये विचार के sin थीटा पॉजिटिव है बराबर in first and second quadrant both तो सब गवर्नमेंट ला sin थीटा ऐड करो तो आंसर तो पॉजिटिव हो जावे ने because cos is pi cos pi minus 1 ને cos 0 1 એટલે મને ખબર હતી 0 તો નહીં જાવે તો 1 ને 1 હોય તો બીજું તો 2 જાવે તો કા minus 2 હોય but minus 2 is not possible okay okay fine let's go to next question વચ્ચે વચ્ચે થોડા સારા મૂકવા પડે ને, બરાબર ને? 23, 24, 25 રિલેટિવલી સિમ્પલ હતું. પછી એક 26 હવે પાછું જો which of the following is true in 7th question. Which of the following is true for the figure showing electric lines of force? देखा है figure, there is point A, there is point B. Yes or no? Okay. So two options are about magnitude of electric field and two options are about potential. Pehla magnitude of electric field. Looking at field lines, how can you decide or how can you compare magnitude of electric field? Who remembers that? Looking at field lines, can you cover whether electric field is more or less? SME? Very good. Closeness of field line. So out of A and D, ME, which one is right according to you? A. Very good. Sit down. You can see at the point A, the field lines are close to each other. Correct or not? That means electric field at A is more than the electric field at B. Clear? Okay, A, B to come full. Now for potential. Okay, we have to decide which is at higher potential, which is at lower potential. For potential, how do we relate field lines with potential? How do we relate field lines with potential? याद करो आज चैप्टर में जाएगा ना तो. Okay. Yeah, Krishna, what's your answer? Maths नहीं, एकदम simple है. Sorry? Yes, electric field lines are pointed from higher potential to lower potential. Yes or no? Yes. Okay, so what would be your answer? D. Correct. D. Because you see B is on such a side that electric field lines are coming from B to A. So B is at higher potential and A is at lower potential. Understood? Yes. Everyone, sit down. Well done. હું તમને નથી કહેતો ઓલા sentences એ યાદ રાખવાના. They will help you in this type of things. Okay? So answer is A and D both. Okay? એક્ઝામ માં એવું હશે તો લખેલું હશે, બરાબર? નહીતર નહીં. Okay, 28. Dipole moment of a system of charge plus Q distributed uniformly on an arc of radius r subtending an angle pi by 2 at its center where another charge minus Q is placed. પહેલા તો આ ક્વેશ્ચન સમજો. Dipole moment ને બધું છોડો, પહેલા ડ્રો કરો શું કીધું. What's the situation like? Draw the situation. What is given? What's there? Where's the charge? And all that. Dipole moment is a scalar or a vector? Scalar or vector? Vector ne? Yes. So याद रखो. So diagram. Let's read this carefully. Charge plus Q, હું તો અહીંયાથી વાંચવા ચાલુ કરું તો આગળના વર્ડ થઈ જાવ. Charge plus Q distributed uniformly on an arc of radius r, subtending an angle. How much angle? Pi by 2 at the center. R draw કરી. એટલે કેવું આવ્યું? ક્વાર્ટર આવે ને? Yes or no? Yes. Like this. Clear or not clear? But let's do it smart. આ ખોટું નથી અને એમાં વધારે મહેનત. Let's do it in this manner that half of it, let's do it in this manner so that half of it is on left side and half of it is on right side. Did you understand what I have drawn? Yes. Clear or not clear? Sure? Absolutely. Aji, आनंद easy करी. Which is better, to remove the figure or બરોબર making it very easy then right easy is better આ વધારે easy પડશે that બે સેમ જ છે પણ બુક કાઢી કરવી જોઈએ so this is the r where is the positive charge it is uniformly distributed on the r did you understand yes clear or not clear तो समझाणु positive charge q how much total charge q is uniformly distributed where is the negative charge at the center here and this angle is 90 degree or ऊपर 45 नीचे 45 okay okay or not okay now we want to find dipole moment so can you see thousands of dipoles to ask you this can you see thousands of dipoles yes बहुत बड़ा okay so if you want to find the dipole moment of this whole thing we will have to do integration of dipole moment is that clear yes we have to do integration of dipole moment right let's start so first of all we're going to definitely exploit the symmetry એટલું તો દેખાય છે ને કે જેમ ઉપર હોય તે નીચે છે so net dipole moment will be towards the right side yes or no yes because dipole moment is from negative charge towards the positive આ ઉપર હોય તો એ નીચે છે so resultant right got that yes so we are only interested in the component horizontal component let's draw something like that again so here is the center here is a small portion let's say its charge is dq positive okay and correspondingly we will just think of a very small charge out of all the total charge minus q let's say there is a small charge minus c got that okay or not okay very dipole it will be in which direction in this direction clear that is dp vector means what small dipole moment in that direction got it sure fine now it will make let's say this is making an angle theta here and this is a small angle d theta જે વાણી પહેલા કર્યું હતું is that clear yes okay just for sake of drawing it I'm drawing it large so that you can see this is that small r which charge dq this is angle d theta so what will be length of the r length of r how much will be length of r r into d theta got that yes r into d theta so the small charge dq will be equal to lambda into r d theta clear how do you find small charge lambda into length yes or no lambda into dl clear but this arc length will be r d theta so lambda into r d clear yes okay હવે શું કરવાનું lambda ની value read the question carefully charge q is distributed on this much length अच्छा length કેટલી હોય આ radius r તો આ length કેટલી હોય quarter circle yes or no yes 90 degree તો શું હોય quarter circle હોય ને what the length of quarter circle pi by 2 2 pi r by 4 that is pi r by 2 okay so here lambda will be this raise your hand if you understood that so great lambda equal to charge upon length how much length pi r by 2 pi yes okay so this is dq this is dq okay so that will be r answer length 2q by 5 dq q is a constant here because q is the total charge this dq don't get confused let's just write that I repeat what I have said don't get confused between this dq and this q so I'm just writing that okay actually we all of them question my bad now this what they do nevertheless so this is dq dash હવે find કરવાની કોણ dipole moment dp small dipole moment કેને find કરાય formula is 2aq એવું જાય ને and so this would be अच्छा खाली magnitude बता 2a એટલે distance what the distance between this and this into dq dash clear or not clear yes 2 નો આવે સમજાણું because the formula is 2a into q. 2a means distance into q. So distance is r into impedance. So that is r into 2q by y into d. Right? R into 2q by y into d. This is which component are we interested in? Cement is an upon the same much. So the resultant will be horizontal. Clear or not? So we are interested in which component? Cos theta. It was in it. Okay, now much ready. This angle will also be theta. So it will be cos theta. So integration and final answer T will be equal to integration of dv cos theta. Clear? Limit. Limit theta equal to અહીંથી ચાલુ કરો તો 0 to pi by 4. પણ એવું બે વાર છે ને ઉપર નીચે. Did you understand? કા 0 to minus pi by 4 to pi by 4 એના કરતા આવી ગયું માઈનસ ની મિસ્ટેક કરો એના કરતા આસાન. What is કરો ચલો ફટાફટ. નાખો a 2 into dp. What dp? R constant, q constant, q constant by pi. Okay, integration. Yes. Then go on to cos theta d theta. That from 0 to pi. Cos integration is sin. Sin pi by 4 1 by root 2. Sin 0 0. बाकी શું છે 2r into q into pi. Sorry, upon pi and into 2 by root 2. So root 2 cancel here. So 2 root 2 r cubed by pi. Okay. Fine. And repeat. R 1 by root 2 I will multiply here. Okay. Well. 29. Very good. આવી ગયું क्या હતું તે હતું nobody I didn't notice it ever. I think now boards can be erased properly. Well, let's go to the next page. 29. Shown in figure, a spherical shell with an inner radius A and outer radius B. Okay, don't be confused. This is a shell, so inside is hollow, but this part is solid. Is that clear? Or two hollow there. Okay, and this part is solid. Okay, what is the inner radius? A. What is the outer radius? B. A point charge plus Q is what? Placed at the center. Okay, here. Total charge minus Q is placed on the shell. On this shell. So this whole shell together has how much charge? Minus Q. વચ્ચે નહીં હોય ખાલી મેં અહીંયા લખી નાખ્યું. Okay, it will be either on inner surface or on outer surface. એવી રીતે આવશે. Now, charge minus Q is distributed on the surface. એમ મને તો ખબર જ નથી. બરાબર ને? ખબર હતી કે નથી ખબર? Charge minus Q. This one, some of it will go here, some of it will go out. So total charge. Suppose this here, whatever charge comes, that we call Q1. and here whatever charge comes that we call Q2. Clear or not? Very simple. This minus Q, some of it will go here, some of it will go there. So Q1 plus Q2 equal to minus Q2. Got it? Got it or not? Okay, now what's the question? We have to decide where how much charge will be there. अच्छा एक एक property है याद से. If you put something inside this cavity, then what's the charge on this inner surface? Opposite of this. So definitely Q1 is equal to minus Q. Okay, using what? Using a property of the conductor. Got it? So into the value. So if Q1 is minus Q, can you easily find out what is Q2? Minus small q plus capital Q. Okay? Minus small q plus capital Q. Okay, which option? એટલે જો આ પ્રોપર્ટીઝ યાદ છે ને એટલી ઇઝી છે નહીં તમે અહીંયા ડિરાઈવ કરવા બેસો તો થાય બટ ઇટ વિલ લુક લાઈક અ સમ there. ઓકે અહીંયા એવું લાગે છે અરે આમ તો કઈ કરેક્ટ ઓર નોટ? ખાલી પ્રોપર્ટી ખબર હોય તો એક સ્ટેપ માં થઈ ગયું. ઓકે તો પૂરું થઈ જશે તમારી મહેરબાની. In the previous question assume that electrostatic potential is zero at infinite distance from shell. Infinite હોય તો સરફેસ થી મેજર કરીએ કે સેન્ટર થી infinite જ રહે ને બરાબર કે રે? It's like saying that my house is very far from here. હવે તમે પૂછો અહીંથી સર અહીંથી કેટલું? Very far જ ને. Clear or not clear?
Yes.
Okay, done. In the previous question, assume that electrostatic potential is zero at infinite. So normal assumption. આપણે એ પણ લેવું છે, બરાબર ને? Then the electrostatic potential at a distance r, where r is less than b but greater than a. ક્યાં છે? વચ્ચે આવશે ને ક્યાં? So this much distance is r. Okay, less than b but greater than a. Find pure. So a is less but b is more than that. Then we have to find what is the potential at that point. अच्छा આ point क्या है? Is it in the hollow part or is it in the body? Body. All points of the body of a conductor have same potential as the surface. Sure? Yes. अच्छा અહીંયા લો તો ચાલે અહીંયા લો તો ચાલે બધાનો આન્સર સેમ જ આવવાનો. Okay, same ના આવે તો ગડબડ છે. So let's take outer. Okay, we'll just find out V on the outer surface. Okay or not okay? Yes. Very enough. How many charges are there that will create potential? 3. Plus Q at the center, Q1 on inner surface and Q2 on outer surface. Clear or not? 3 charges are there. Got it? Got it or not? So V equal to V due to 1, V due to 2, V due to 3. Okay, due to 1 at a pointer. At this point. Now, sorry, not at R. At this distance. एक बात तो तुमने को R वाला ऑप्शन डाउन है. Is that clear or not clear?
Yes.
समझ पड़ेगा नहीं? Yeah. Okay, let's find it here. So due to point charge, first one point charge. A Q by B. Clear or not?
Yes.
By B. Distance is B. Yeah. Fine. Okay. My second is a inner. અહીંયા જે આ charge છે minus Q minus that one. Okay. So this charge on the inner surface is like a shell. Yes or no?
Yes.
समझ पड़े? It's just like a shell. So due to a shell at this point. Okay. This point is it inside the shell or outside the shell? Outside. Okay. Outside the shell you want to know. A Q. What should I write for Q? Minus capital Q. Correct. Because the charge is minus capital Q. Into divided by B. Distance है ना?
Yes.
B. Clear?
Yes.
अब into 0. Third is this charge here, whatever there is over here. Into the opposite. For this shell, for this layer, for this shell, this point is on the On the surface. Okay or not okay?
Yes.
On the surface. So on the surface of that K Q the charge to the capital Q minus small q divided by D. Got it?
Yes.
Radius in feet. So which option? Which option? D. Clear? Okay. 31. Plates A and B constitute an isolated charged parallel plate capacitor. Capacitor na નામ થી ડરી જાવ નહીં. It has nothing to do with the capacitor. Okay, એના વગર એ solve થઈ જશે. In the inner surface 1 and 4. દેખાય છે 1 and 4. Okay, of A and B have charges how much? Plus Q and minus Q respectively. Okay, let's draw this. This is the plate. This is the other plate. And this is one more plate. A, C, B. On this one, it is a Q1 goal. Q1. How much is Q1 plus Q? We don't know what is Q2. We don't know what is Q3. And we know what is Q4. How much is the 4? Minus 6. I said a 4 minus. Okay, I don't like Roman letters. How much is the 4? So 1, 2, 3, and 4. Clear? Yes. Fine. What's the question? A third plate C with a charge plus Q is now introduced midway. Then we put it here. Okay, then we put it here. So these were the charges earlier. These were the charges earlier. Now we bring this. A pay diagram there. First, this is the diagram without that. And now we bring this here. Then, which of the following is not correct? Okay. Now just one thing is that in any kind of capacitors, the plates or whatever there is, it is made up of metal. Okay, so these are all metal conductors. Okay. They are conductors. Got it? Right? They are all conductors. Okay. We'll have to decide about the surface. What is the total charge of C plate? Plus Q. Okay, total charge. Some of it will go here and some of it will go here. Clear? Clear or not clear?
Yes.
Actually, Q3 will be equal to Q minus Q2. Yes or no? Conservation of charge. No. It has total charge Q. Even if some of it flows, then the total will always remain same. If you addition karo to Q. What will? Okay. So we have this. Now we will find. See. We don't know how much charges will be there everywhere. Right? It says surface 1 and 2 will have equal and opposite charge. Surface 3 and 4 will have equal and opposite charge, and so on. So we have to descend. Right? These were actually the initial charges. I think we should make it very clear. These were the initial charges. Okay, these were the initial charges. What happens now? There are various ways to go about it, right? But suppose I would take one point here inside this plate. Let's maybe call it D. What will be the electric field at D? What will be electric field at D? 0. Not clear? Why 0? Metal plate. How metal plate the under inside the metal plate or inside any metal? What is the electric field? Got it? Property of conductor. Clear or not?
Yes.
Okay. Like that, if I take one point E here, what will be the electric field at E? Over here, but that's zero. Is that fine? That is what we will use to find out the charge. This is the basic idea. That's what we'll use to find the charges. Okay. Now, we are given that on this one there was a charge Q earlier. On this one. On this one there was a charge minus. So let's go to E first. Same E, I'll tell you what. Because if you take this, then all this charge plus Q is on left side of E, and all this charge minus Q is on right side of. So if you go to E, electric field at E should be 0. Now that is only possible, see, going through the proof. Now suppose sigma 1, sigma 2, sigma 3, sigma 4 everything. Did you understand? Clear or not clear? Sure. Or not clear? Sure?
Yes.
Akune? Then electric field at E is always 0 if the electric field from both sides will cancel each other. So, do you realize that it will give me sigma 1, which is positive here, there is positive charge on this side. Assuming Q2 is positive, should be equal to Q3 sigma 3, sorry, minus sigma 4. Yes, no. Kf divide by 2 epsilon 0 to epsilon 0 to epsilon 0 to epsilon 0 to so that electric field line and the total electric field from left side and total electric field from right side should be balanced. It may be equal. Clear or not clear?
Yes.
Sure. Okay. So, what do we get here? Sigma 1 એટલે એની જગ્યાએ લખી શકાય q by a પણ એરિયા બધાને સેમ જ છે તો q1 પ્લસ સ્મોલ q અહીંયા તો ખાલી q છે because this total charge will always remain q. Clear or not clear? This total charge will always remain q. So q plus q2 equal to q3, but here instead of q3 we will write q minus q, and then here there is minus q. Why? That surface charge density is q. Got it? Now minus already negative છે એના માટે જ છે. Is that understood? Neither the plus જ આવે પણ આ તો sign already હું મૂકી જ દઉં છું એટલે આપણે ખાલી હવે magnitude જ મૂકવાનું પડશે. Did you understand?
Yeah.
Sure. So this is what we get. अच्छा हम कैसे simplify करें? What do we get? 2q2 equal to minus 2q2 equal to minus q. Therefore q equal to minus q by 2. So આ બાજુ minus q by 2. અને આ બાજુ શું આવશે? 3q. Did you understand? Did you understand or not? Clear? On one side we got minus q by 2, on the other side we got 3q by 2. अच्छा પછી આગળ છે ને હજી એક વસ્તુ કરે 10 પર કેવું થાય ખબર છે આગળ કેપેસિટર માં આવશે what happens is that facing sides take equal and opposite charge એટલે અહીંયા minus q by 2 હશે ને તો અહીંયા આવી જશે plus q by 2. Did you understand? એવું કેમ થાય પછી આગળ સમજાય છે minus q by 2 q by 2. Okay, but this total was q, wasn't it? And equal q wasn't it? So remaining q by 2 will go on this side. Did you understand? Okay, remaining q by 2 total was q. This is q by 2, so remaining q by 2 will go up here. Similarly, this is minus q by 2, 3q by 2. હવે અહીંયાથી q by 2 તો અહીંયા શું હશે? Minus 3q by 2. Did you understand? Same way, like I said, facing surfaces that are opposite to each other, they will take opposite charge, and here we will get q by 2. Did you get that?
Yes.
Okay. You get that or not? Right? So this is how the whole thing works out. Right? હવે આ બધામાંથી ડિસાઈડ કરવું તો શું થાય? Surface 1 and 2 have equal and opposite charge.
Yes.
Yes or no?
Yes.
B. Surface 3 and 4 have equal and opposite charge.
Yes.
Yes. But the charge on surface 3 will be greater than Q.
Yes.
Yes. But the potential difference between A and C will be equal to potential difference between C and B. The potential difference क्या इलेक्ट्रिक फील्ड થી કરાય ને ઓકે આ બે વચ્ચે ઇલેક્ટ્રિક ફીલ્ડ ફાઇન્ડ કરતા આવડે આ બધા ચાર્જીસ ઓકે then you can do integration or for uniform field યાદ છે ને minus e vector dot delta r vector એ બે માં કરી દો અહીંયા આ ડિસ્ટન્સ જેટલું છે એટલું જ અહીંયા આઇડેન્ટિકલ બધું યુનિફોર્મલી ડિસ્ટ્રીબ્યુટેડ છે એનાથી જો કે બહુ ફરક નથી પડતો કે ફીલ્ડ યુનિફોર્મ છે. But here, this charge is only Q and that charge is 3Q by 2. So here the electric field will be stronger. Make sense or not? Yes. That's why the potentials will not be same. The potential differences will not be equal. We have to pick the not correct statement. Clear or not? The answer will be D. A, B and C are definitely right. Okay.